Hi friends, my name is K. Sharad Kumar. Today I am going to tell about my second assignment of physics. Topic name is Classical Free Electron Theory. Subject name is Engineering Physics. Subject code 23PHY01. My role bearing roll number 244G1A05BH. I am from Computer Science and Engineering. Let's getting into the topic. Introduction to Classical Free Electron Theory. Classical Free Electron Theory explains the electrical and thermal conductivity of metals. It models the electron in the metal as a gas of practical, free particles moving in a lattice and positive ions. The theory, the theory is foundational in understanding the behavior and metals and their electrical properties. We can see in the picture they have explained about the classical free electron theory of metals. Uh, the free electrons theory is based on the following assumptions. Okay, we can go for next topic in the classical free electron theory. That is historical background. The theory emerged in the early 20th century, building on earlier models of atomic structure. Physicists Notable physic- physicists such as Drude and Lorentz contributed significance to its development. It was pivotal in explaining and phenomena such as electrical conduction, thermal conductivity. Physicists. Key assumptions. The theory assumes that electrical behave as a free gas of particles without significant interaction. Physicist. It is also pre, pre presumes that the metal lattice remains fixed while electrons move freely. Another assumption is the effects of the temperature of on electron movement can be neglected in certain conditions. Electron gas model. In the electron gas model, electrons are treated as non-interacting particles in a potential well. This model allows for the calculations of various properties such as conductivity and heat capacity. The concept of Fermi energy is central to the understanding of the distribution of electrons in this model. We can see the valency electrons in the picture. Electron shell 1 to 7. Number of the electrons. For electron shell 1 is contains 2 electrons. For electron shell 2 contains 8 electrons. For electron shell 3 contains 8 electron shell 4 contains 18 electrons, 5 contains 18 electrons, shell 6 contains 32 electrons, electron shell 7 contains 32 electrons. That is the valence electrons. Electrical conductivity. Classical free electron. Classically free electron. The theory explains conductivity through the movement of the electrons when an electric field is applied. The drift velocity of electrons are The drift velocity of electrons in response to an electric field leads to a current flow. The conductivity is directly proportional to the number of the free electrons available for conduction. Thermal conductivity. Thermal conductivity in metals also attributed to the free movement of electrons. Electrons transfer energy through collisions with the lattice, facilitating heat conduction. This leads to the observation the method. This leads to the observation that metals often exhibit high thermal conductivity alongside electrical conductivity. Limitations of the theory. Sorry for the inconvenience. Limitations of the theory. Classical free electron theory does not account for electrical electron interaction effectively. It fails to explain phenomena such as temperature dependent of resistivity at low temperature. This theory cannot accurately describe the behavior of insulator and semiconductor. This theory cannot tell about the behavior of insulator and semiconductors. Comparing with quantum theory. Quantum mechanism introduced new models that address the limitations of classical free electron theory. The Fermi directions statistics provide a more accurate description of electron behavior in solids. Quantum theory considers the wave particle duality, duality of electrons, enhancing our understanding of conductivity. I am audible. Sorry for my inconveniences. This is about the classical free electron of theory. Thank you.